So those of you starting tomorrow, I'm both sorry, but also wishing you the best of luck. I hope they go well. Yeah, I echo that all. I mean, really, good luck, guys. You've prepared, you know what you're doing, and just go in with confidence. That's the most important thing. If you've prepared, you will be absolutely fine. Okay, wow. All right. That was a shock to my system, and I'm not even writing trial exams. Okay, so guys, on Monday, I said to take a screenshot of this question. And we only got to question B, but I said take a screenshot, give it a try, and then I'll put up the answers for you. So the next question, whoopsie daisies. The next question that was asked of you was apparently nothing. So that's, there we go. Was to calculate the coordinates of C. And so C is your turning point on your parabola, which is over here. And so because you had your parabola equation, we'd already determined the parabola equation, you could just use that formula minus b over 2a, get your x value, substitute that back into, and get your y value. Alternatively, if you wanted to, we know that a turning point on a graph is where the first derivative is equal to 0. So if you wanted to use calculus methods in order to figure out your turning point, you were more than welcome to. You would find the derivative of this expression, which is 2x plus 2. Again, get your x value and then substitute back. There is actually a third method of doing this, which is to complete the square. But quite frankly, why you would want to do that, I don't know. But you could complete the square if you really wanted to, and you could get your turning point. Completely up to you. That would be the last thing I would want to do, but 3 different ways to do the same thing. The next question asks you to write down the range of f. F is your parabola. So now that you have your turning point at C and you know it's at -1, -4, you know that your range is from this turning point all the way up. So that's why it's y greater than or equal to -4. You can write it in any format you want, interval notation or inequalities. I prefer inequalities personally, but that's up to you. E asked you to determine the equation of the line through C that makes a 45-degree angle with a positive x-axis. Write your answer in. We'll get to that now. So, if we go and have a look at what that line would look like, I'm just going to take off some of these scribbles here. It's a line that has to pass through D and then make a 45-degree angle with your axis. Now, obviously, this is not necessarily drawn to scale, but I'm going to do my best. So it would be a line, straight line, something like that. So it would help if it went through C. Okay, there through C. And it would then create a 45-degree angle. Now, this is actually bringing in a bit of analytical geometry because we know that this angle created between your positive x-axis and a straight line would be, if you took the tan ratio of that angle, you would get your gradient. And so that's what we expected you to do here. So that's exactly what we've done. Tan 45 equals 1 because tan of 45 degrees is 1, which means that you know your m value is 1. And then because we told you it passed through C and you had just worked out that C was at -1, -4, you would substitute in that coordinate in order to calculate the y-intercept. And so you got that y was equal to x minus 3. Now, I did take it off, but point D in the information of the question, we were told, were we told? Oh, no, we weren't told, sorry, point D, but you could go and work it out. No, were we told? Oh, no, we were told point D. Sorry, I was losing my mind here. That was weird. And so we did actually know what point D is. And so what you need to notice is that, I'm just going to make this a touch smaller, is that this y-intercept of the straight line you've just worked out is at -3. And so this straight line actually passes through the coordinate D as well. It goes through that y-intercept at -3. And so what that means is now when it gets to question F, where it asks you, is the straight line determined in question, well, the question before, a tangent, The answer is no, because it's passing through 2 points on your parabola. A tangent can only touch once, generally externally to your curve. And so unfortunately, or in this case, it would not be a tangent. Kanye, do you see your question? I will chat to you now. I'll go back to the range now. And then the final question, G, says the function of h of x is equal to f of m minus x plus q has only one x-intercept at x equals 0. Determine the values of m and q. Okay, so this question, we needed to do a bit of manipulation. There were a few things that you could deal with. Do your English. There were a few things you could do here, but there was a bit of manipulation involved. So the graph of f was x squared plus 2x minus 3. F was x squared plus 2x minus 3. And so what we needed to do is we needed to understand what this reflection was telling us. Okay, so what we could do is we could take out a common factor of a minus in, the words have escaped me, which is obviously a problem because, you know, we need words to do this. We could take out the negative in the bracket. And so what that would leave us with is f of negative x minus m. And then again, we need to understand what that transformation is saying to us. All right, so so this negative, whenever x is negative, this is a reflection in your y-axis. So that negative coefficient is a reflection in your y-axis. It then tells us that we want it, or it only has one x-intercept. So your parabola, when you shift it, needs to cut your x-axis once and once only. So if we go and have a look at our beautiful parabola here, this turning point, which is currently at -1, -4, needs to move 4 units up so that it now sits on my x-axis. And so that's why this next little bit that it says here is translated 4 units upwards. Okay, excuse me. It then goes on to say that that x-intercept is specifically at 0. So again, if we go back up to our graph, this graph now actually has to move over to intercept at the origin. In order for my graph to move over, it would need to go from -1 to 0, which is a shift left by 1 unit. And so this is why it tells me it's also shifted 1 unit to the left. And so that bracket, this bracket needs to express a move to the left. So x plus 1, which is why m needs to be negative, and q needs to represent my shift 4 units up. All right, this was not a particularly easy question, I'm going to be honest, because of the fact that you needed to manipulate that bracket before you got going. But always remember, when you get questions like this where there's a transformation, firstly, understand what the transformation is saying to you. So what I mean by that is understand that this bracket represents a shift left or right, and understand that that Q represents a shift up or down. Go a step further, and with the rest of your information, visualize for yourself what that would mean for your graph. So this 1x intercept meant the turning point needs to be on the x-axis. This at x equals 0 means that it needed to move over to the origin. And then you can start to put in place all the translations or transformations that needed to happen in order for you to get the graph that you wanted. Okay, so when you deal with transformation questions, they aren't necessarily always easiest, but go step by step and break down what each piece of information is saying to you, and then you can go from there. Right, I will let you screenshot all of this in a second, but let me just go back up to the question of the brackets confuse me by the range. Kanye, I'm going to be honest, I don't like using the bracket form of the answers. I don't like interval notation either. But basically, square brackets means your values are included. Round brackets mean they are excluded. Now, we will never ask you to write an interval notation. We will never specify that your answer must be written in a certain way. So you can choose. And personally, I will always go inequality. For me, that's easier. However, you need to decide where the values are included or excluded. So because this was the range of my parabola, my range is all the y values. So basically from the turning point, terrible straight line. So from the turning point, I've got graph and all the way up from my turning point. Now up is towards positive infinity, and this turning point of my parabola is at -4. Because I do actually have a point at -4, I must include it because I do find a point on my graph there. And so that's why over here, I have a square bracket because -4 does actually have a coordinate there. There is a corresponding x value. Infinity is never included because we don't know where infinity ends. So we cannot put a square bracket there because we have no clue where it ends. And so -4 because there is actually the turning point there all the way up to infinity. However, like I said, we're never going to tell you how to write it. So I would just go with the inequality personally. All right, but the brackets included, excluded when it comes to range, domain, anything like that. Lorato?
Ma'am, so since you say that we have a coordinate by the -4, we put in like the square brackets or that line at the bottom of the equal to for the interval. Does this mean if we didn't have a coordinate by the -4, it would just be excluded?
Yes. So a good example of that would be something like an exponential, which we're actually going to have a look at in a second. But let's say we had an exponential function that was like this, and this was an asymptote at, I don't know, y equals -3. Do you agree that my graph exists just above -3? Not at -3 because it's an asymptote, but everything above -3, I've got a graph.
Yes, ma'am.
Okay, so this is now where I'd say y is greater than -3, but I wouldn't include the -3 because there's an asymptote there. There's no coordinate at that line. Whereas here, like you say, there is actually a coordinate, so I need to include it.
Oh, okay, ma'am. Thank you, ma'am.
Okay, good. Okay, so guys, asymptotes, just in relation to Lorato's question there, asymptotes will be the ones that won't have the included sign with your inequality. There are a few questions that we're going to have a look at now that deal with range and stuff, and like I say, of exponential functions. So you will see how we do this, and what I'll do when we do those answers, I will write down both the interval notation with the brackets and the inequality, just so that you can see both. But my advice, guys, like I say, because we're never going to say you have to write your answer like this, use the one that makes more sense to you. If the brackets make sense to you, use it. If the inequality makes sense to you, use it. Do what you are comfortable with because that will obviously get you the marks. Okay, let's just do this so you guys can take a screenshot of all those answers. I'm sorry, it's going to be a touch small, but you do have a screenshot of the original question. So that's all the answers that you need from here. And then we're going to jump straight into our inverse functions. Right, and then guys, just remember as I go along, if at any point you don't understand, you need me to explain, you want to jump in with something, maybe you've learned something a different way, or you can do something easier, please just jump in, put a message on the chat, whatever the case is, so that we all feel comfortable afterwards. And yeah, if there's any problems, you just let me know. All right, so let's jump into our inverse functions. Sorry, I need to have a cough. And I don't want to do that in your ears. All right, just so that you know, we are going to be doing algebra in the next boot camp. You might think, oh, algebra, it's fine. Remember, algebra is pretty much all. There is nothing new in algebra. In that first question that we do in matric, your new matric algebra is all calculus, and we're going to do a whole other session on calculus. So it is all grade 11 work that we're going to be talking about next week, which you might think again, oh, I don't need that. But when was the last time you did it? Probably in your June exams and never again. So I would really recommend you come to the algebra just because it's a refresher of all the things you've learned in grade 11. And for some, it was a while ago. All right, but let's jump straight in. So I need to make my questions bigger. So this was from some point in time, September 2022. There we go. And again, guys, your inverse function questions is not the bulk of your functions in your exam. It really isn't. But obviously, you need to be able to do them because of the 35 marks, it's between 10, 15 marks, which, again, not the majority, but a decent chunk. And so if you can do the inverse functions, you are banking a lot of those function marks for yourself. Alrighty, so, excuse me. This first question, and this is again from the mock from 2 years ago, or trial exam from 2 years ago, says, draw the graph of f in your answer book. Okay, we don't have an answer book, it's fine, we're just going to use an axis. Clearly show the intercepts with the axes as well as the asymptote of the graph. And the graph they're asking us to draw is this f of x graph at the top there, -3 to the power x plus 1. Now again, guys, before I even get into sketching my function, I would want to break down each of the transformations that are happening. So firstly, this is a nice, easy one to start off with, this plus 1. What does that mean has happened to my original graph? So if we had, now this is an exponential graph, I probably should have started with that. What does this Q value represent on my graph? What does it do? So for you?
Isn't it the asymptote, ma'am?
Excellent. Okay, so this is the asymptote of my graph, and it obviously told me I need to show the asymptote, and you always need to show asymptotes. So it's your asymptote. You could have said the shift up or down. It's really up to you. But this would be shift 1 unit up. But importantly, it's the asymptote. Does anyone know what this negative in front of my base tells me? So this A value here, if that's negative, what does that mean?
Not really.
Nice, Bongi and Corsi, well done. It means that your graph, your exponential graph, will sit below your axis. Okay, in terms of increasing and decreasing, yes, it does show that, but the increasing and decreasing links a little closer with the B value. So in Monday's lesson, and this is on Google Classroom, if we just go back up here, sorry. If we look at these exponential summaries that I gave you, so the increasing, decreasing situation is determined by B, but because A is negative here and the B was 3, it would be a decreasing graph. So they all link at the end of the day, but what we do know is that it'll sit below my asymptote. All right, so we can now take all of this information and we can start sketching our graph. Now, guys, remember, this is a sketch. It doesn't have to be perfectly beautiful. Here, it says in your answer book, so you would have been given an answer book with an answer sheet. And so you would just use what axis was given to you. The first thing I would always sketch is my asymptote. So this was an asymptote at +1. It's really going to upset me that this looks so horrible, but whatever. We're just going to pretend we're okay with it. And remember, label your asymptote y equals 1. You label it with its equation. Any graph, you need to show the intercepts with your axes, and so I'm going to need to determine that. You can start with whichever one you want. It's completely up to you. You might already know where the intercept with the axis will be, and then you don't need to do any calculations. But if you didn't, I'm just going to do the y-intercept because I can clearly see that because my graph is going to sit below my asymptote, there will definitely be a y-intercept. for exponentials, there is always a y-intercept, but there isn't necessarily always an x-intercept. It depends where your graph sits. So if we want to find the y-intercept, what do we do? Who can remember? Nice, Awami. We make x equals 0. So we will have y is equal to -3 to the power 0 plus 1. Now, anything to the power 0 is then 1. So this is y is equal to -1 plus 1. And so this is telling me that my y-intercept and actually my x-intercept is at the origin. So this graph has to pass through the origin. Now, once again, if you are comfortable and confident with what your A, B, Q values all tell you about your graph, then cool, plot your graph. But if you aren't comfortable, just find another point for yourself so that you can plot this confidently. All right. So you can decide whatever x value you want to substitute into your function here. I don't know why I'm panicking with this, but apparently I am. And I'm just going to substitute in x equals -1. You could have picked -2. Why am I putting -1? I want to put 1. You could have picked -1, +2, whatever you want. Any x value you want, as long as you substitute it into the given equation, it will be a point on the graph. So I'm going to substitute in x equals 1 to find another point just to help me with my shape. And so this would now be y is equal to -3 to the power 1 plus 1. And so this would be y is equal to -3 plus 1, which is -2. So at x1, I go down to 2. And what this allows me to do, my graph is going to be atrocious, so just bear with me. I'm going to have to do this in parts. What this allows me to do is it allows me to see what the general shape of my graph should be. You wouldn't think this would be so hard, but it is. Right, there we go. And so there is my, why am I saying G? And there's my graph of f. Okay, it's not the best exponential function I've ever drawn, but we're just going to pretend it's fine. That's it. We've got our x-intercept and our y-intercept. If you've drawn another point, always just label it. It's always nice to have at least 2 points on any function that you have. And so that's it. 3 nice, easy marks. You get a mark for your asymptote, a mark for the shape of your graph. So understanding that it is, in fact, a decreasing graph, that it doesn't like have a 90-degree angle. All of those things, you get a mark for the shape. And then you get a mark for the x-intercept. So that's 0, 0 point. Okay, so drawing a graph, it's going to be a sketch. Obviously, you can use a table method on your calculator if you want to, but like at this point, we should know what the general characteristics of our graphs are and be able to sketch it. Right, I'm just going to wait 2 seconds in case you want to screenshot all of this. And then we'll have a look at the next one.
Ma'am, I'm confused. How did we get the x equals to 1?
Gosh, I'm so sorry. That was just a coordinate I substituted in. So I wanted to get the general shape of my graph. And so what I do is I just pick any x value. You can pick any one you want. And I substitute it into my graph in order to find the corresponding y. And what it just helps me do is it helps me get the general shape of my graph so that I can plot it accurately.
Okay, so you can pick any x coordinate, intercept.
Any one. So if you had decided, I don't know, x equals -1, y equals -3 to the -1. Obviously, I've made my life hard now. Plus 1, which is y is equal to -1/3 plus 1. And so y is equal to 2/3. So here at -1, this would be at -1 2/3. Any coordinate you want just to get the general shape.
Okay, ma'am.
Okay. So guys, this isn't like, it's not like a must to find that coordinate, but if you aren't sure about the shape, rather just find another point, or even if you need another 2 points, rather find them so that you plot your graph accurately and you don't make a silly mistake and lose a mark. Right, so it's just to help us a little bit. Right, the second question says write down the range of f. So this is exactly what I was saying earlier. This is my function of f, and range refers to y. Now, I think I've said this to you guys before, but I also might be dreaming. What I like to do is, particularly if I'm struggling to find the range, I take my ruler and I put it, you can put it at the top or the bottom of your page, it doesn't matter. Basically, what I do is I move it down. The second I start hitting graph, I know that it must be included in my range. So I'm actually going to go from the bottom. It's easier. All the way to negative infinity, I've got graph. My line is hitting graph, hitting graph, hitting graph, hitting graph, all the way up until I get to my asymptote. Anywhere above my asymptote, I no longer have a graph. And so what that means is my graph exists from my asymptote all the way down to negative infinity. So again, if you struggle with range or even domain, just take your ruler, put it on the y-axis for range, put it on the x-axis for domain, and move it until you no longer have graph, and that will define your range. So here, because this is below my asymptote, we would say y is less than 1. We do not include the 1 because it is an asymptote. There is no graph at y equals 1. And if you wanted to write it with your brackets, you would say y is an element of. And when we write our brackets, we always start with the smallest number for y. So the smallest number for y in this case would actually be negative infinity. And because it's infinity, we use a round bracket, all the way up to positive 1, which must also be a round bracket because it is an asymptote. Right, whichever one you want to use is absolutely fine. Again, I prefer with an inequality, but if you want to use the brackets, that is 100% okay. So exponentials, again, this was a little note that I did put up. Exponentials, your range will depend on your asymptote. Oops, that's not an A. If it sits, so if A is greater than 0, so if A is positive, your range will be y greater than your q value. If A is negative, like we had here, so your graph sits below your asymptote, your range will be y less than your q value. And this, again, is all on that summary sheet that we looked at on Monday, but that's just a little reminder for you that your asymptote determines the range of an exponential function. Lorato?
Ma'am, so when we're writing the range of a straight line, we usually say y is the element of real numbers, like put it like that. But then for exponential, it's just an inequality or the brackets. We don't have to include the y as the element of real numbers, then put the inequality or brackets.
No, because so for a straight line, beautiful straight line, this line just keeps on going from negative infinity to positive infinity with respect to both y and x. There's no point where the graph doesn't exist. Whereas for the exponential, because of that asymptote, there is a part on my Cartesian plane where I will not find graph. And so I can't say element of real because it isn't all real numbers. It's only some of them. And so that's when we use the inequality.
Okay, ma'am. Thank you, ma'am.
Okay, good. Right, question C says, determine the equation of the asymptote of g, given that g of x is equal to negative f of x. Right, so we're not even going to stress about this first part of the question. We're first going to understand what this is saying to me. So we know that g of x is equal to negative 3 to the power x plus 1. I'm panicking now. Yes, we do know that. Does anyone remember what this negative in front of your f of x? So what does it mean if we make the y values negative? What happens to your graph? What transformation happens? Ooh. Nice, Lebel. This is a reflection about your x-axis. So anytime y, there's better words to describe what I'm trying to say. is made negative, it is a reflection about your x-axis. If x is made negative or the x sign changes, it's a reflection about your y-axis. So if we wanted to write down our equation for g of x, obviously I've put the wrong letter there, so let's fix that. If we now wanted to write down the equation of g of x, what I would need to do is I would essentially need to multiply my equation of g of x by a -1. And that's exactly what it is there. It's a coefficient of -1, so I'm multiplying by -1. And so what that means is that g of x is now positive 3 to the power x, but -1. And we've just said over here that if we want to write down anything to do with an asymptote or a range, this q value in my formula is very important. And so now we know we have an exponential function where we have an asymptote at y equals -1, but now my graph is going to increase, be above it, because a is now positive. We can now write down the asymptote. Y is equal to -1. Obviously, you don't have to sketch the graph if you don't want to, but understanding what the transformation is allows us to figure out what's happened to my graph and understand where things have changed. If the asymptote has changed, if the shape has changed, if a coordinate has changed, etc., etc. All right, so this new asymptote, y equals -1. Right, question D says, if g is shifted 1 unit upwards to give a new function h, determine the equation of h to the -1, the inverse of h in the form y equals. All right, so again, let's just break down what we have. We have just worked out that g of x is equal to 3 to the power x minus 1. It tells me that g is shifted 1 unit upwards. So what would the new equation be after I've shifted it 1 unit up? What would the new equation of g of x be when I shifted 1 unit up? Nicole, excellent, just 3 to the power x. If you're not too sure, remember a shift up or down means that you are adding to your q value. So we would then say +1 here, and -1 plus 1 is 0. So it's just 3 to the power x, no problems. Now we can go to the inverse situation. So you go with what you're comfortable with. However, excuse me, we know that h of x is this exponential 3 to the power x, and I now want the inverse function. That is what I'm looking for. Now remember, an inverse function is when we reflect this graph about the line y equals x. And so basically what we need to remember that means is that we swap our x and y's. That is what the reflection about that line means to us. So our equation currently is y is equal to 3 to the power x. We now need to swap the x and the y to get x equals 3 to the power y. And this is now where our logarithms come in. The log graph is the inverse of an exponential. And so if we have y is equal to 3 to the power x, the log form of that would be, let me not panic, y, no, sorry, x. This always gets me, and it's so stupid because I can do it in my head quickly, but no. X equals log of your base, whatever that base may be, to the answer that you have here. So we need to be able to convert this situation, and let's actually write the b here rather. No, it's not going to allow me to do that. We need to be able to convert from exponential to logarithmic. So I always tell myself it's log base of whatever the answer is. There we go. Let's do that. And so now that we've swapped, we can go and write it in logarithmic form. So this would be y is equal to log of your base, which is 3. Nope, let's write it as a base maybe, to your answer x. So y, the exponent, is equal to log of your base to whatever that exponential expression is equal to. Obviously, if you can do all of that in your head without the long-winded explanation, lovely. All right. But you do need to be able to convert from exponentials to logs. Remember, your base, as I had sort of made a silly mistake here, is like a subscript. So it's a small little base 3 or base 2 or whatever it is just below the log, and then your x value. There's no more exponents that we're working with when we convert to a log. All right, so this was a relatively straightforward inverse question because realistically, the only inverse I was actually asked, or the only question about an inverse I was actually asked, was right at the end. Right, so I'm just going to make that a tad bit smaller so that you can take a screenshot. You have actually taken a screenshot of the first bit, sorry. So let's do that. And then we'll have a look at our next set of questions. Lorato?
Ma'am, do you mind going again, explaining again where you did the log? I kind of cut off it.
No, that's fine. I'll explain it again. Just going to wait 2 seconds for everyone to take screenshots, and then I'm going to explain again. All right, so let me just take all of this off. So we are wanting to find the inverse of our function here. And so what that means is I need to take this h of x equals 3 to the power x, and I need to convert it to a log. First things first is you need to swap your x and a y because that is what the inverse is telling me to do. And then you go and write down your base, your log. So we take the exponent, that becomes what it's equal to. So y equals log of your base, so 3, to the answer that your exponential expression would have been equal to. So for example, if we had 3 to the power x equals 9, we would have log of the base 3 to the answer 9 would be equal to my exponent. So you can solve exponential equations using logs. Obviously, that one we could do quite easily without, but that is why logs are so useful, because it allows us to solve exponential equations. And so you could just type that into your calculator and get your answer. But it's log base of whatever the exponential equation was equal to will give you your value, or your y value for that log expression. Alrighty. So let's have a look at this next one. This was a little neater in terms of the inverses. Sorry. I'm a little worried that we're not going to see all of these questions because obviously I've made a choice here now. Okay, sorry guys. Just because I don't want anyone to not be able to see what's going on, because that would obviously be completely useless to you. Nope. Yeah. Sorry guys, obviously technology is panicking. Whatever, okay, it's fine. Right. So this is 2019's paper. Sketch below is the graph of f of x equals k to the power x. K is greater than 0. So that's important. They've given us a bit of information about k. However, grade 12s, please remember that your base is always positive. So if we go back to the general form of our exponential graph, f of x is equal to a times b to the power x minus p plus q. Your base value is always positive, always. It is the a value that can be positive or negative. That is where the negative will come in, the coefficient to your base. But your base is always positive. So when you go and solve for things like your base, as it asks us to do in the first question, that is something we need to bear in mind. It says the point 416 lies on this graph, so that's over there. And we've actually also been told where the x-intercept of this graph is. Now, importantly, grade 12s, if we look at the equation, there is no plus q. So the asymptote for this graph is actually the x-axis at y equals 0. There is no shift up or down for this graph, so my asymptote is the x-axis. Right, but the first question says determine the value of k. So who can tell me what they think we need to do here to find what the value of k is? Zavuyo?
Substitute the x coordinate. I mean, the coordinate that we got. The one that's
Okay,
given.
and which? Perfect, the 416.
Yes, ma'am.
Excellent. Okay, so guys, that's exactly it. Whenever you're trying to find an equation, if you've got a coordinate that you can substitute in, do so. We would not substitute in our y-intercept, which would be at 0, 1, because if we substitute in x equals 0, what's going to happen is we're going to have k equals 0, and that's going to get rid of the k. That's a problem. I'm trying to solve for k. So always just be mindful of that when it comes to the exponential functions. You only want to substitute in an x coordinate of 0 if you need to temporarily get rid of that base. So if there's other things you need to solve for in addition to your base value. So we're going to substitute in, which is 16 is equal to k to the power 4. And then, guys, this is the most basic of exponential equations. There's a few different, actually there's not, sorry, I don't know why I said there's a few different. No, there are. There's two different ways you can do this. Either you can fourth root both sides, bearing in mind that any even root must get a plus or minus. Alternatively, you can write this, I'm getting there. Don't know why this is so hard. You can write this in prime base form. So this 16 is 2 to the power 4, which means 2 to the power 4 is equal to k to the power 4. And this is a bit of a flip. The exponents are already equal, which therefore means in order for this equation to actually be true, so for left side to equal right side, k must be equal to 2. All right? And so the value of k here is equal to 2. If you didn't want to do that and you wanted to fourth root, you would fourth root your 16 and you would fourth root your k to the power 4, bearing in mind that it's a plus or minus. And so k is equal to plus or minus 2. But as we said, b is always positive. And so again, k is equal to 2. I probably wouldn't go the fourth root way, but it doesn't matter how you choose to do it. It gives you exactly the same answer. All right, so we've got k is equal to 2. And so f of x is equal to 2 to the power x. That wasn't the question. It's not asking for the equation. But having the equation now does help us in later questions. Zavoyo, do you still have a question, or was your hand from earlier?
No, ma'am.
Okay. Lorato?
So, ma'am, I went with the fourth root way. So, since, ma'am, we know that the b value is supposed to be a positive, can't we just like make it like the final answer show that it is a positive?
Yeah, absolutely, you can. Because we should know that you absolutely can. I'm more just putting it out there to remind you because often we forget it. But yeah, in this case, go positive. That's absolutely fine.
Okay, ma'am. Thank you, ma'am.
Pleasure. All right. The second question here says, graph G is obtained by reflecting f about the line y equals x. So immediately, what does that mean? What are we looking for if we reflect about the line y equals x? Nice level. This is an inverse. Guys, the second you're working with functions and you reflect about the line y equals x, it is the inverse function. Leila, nice. All right, so we need to use the same logic. We know that f of x is equal to 2 to the power x. I'm just writing it in terms of y because we know we need to swap x and y. And now we can write this in logarithmic form. Y is equal to log of my base to the x, and that is the equation of g. So it asks in the form y equals, so we leave it like that, but we do now know that g of x is equal to log base 2x. Right, so not too tricky. And like I say, if you're comfortable with logs, you can pretty much go straight to the answer. That's fine. But just remember that we swap the x and the y, and then we apply our conversion. But you do you, right? We're not going to like take off a mark if you don't show the swap. As long as you get your log, you're good. Question C says, sketch the graph of G. Indicate on your graph the coordinates of the 2 points. All right, so what that means is, hello. So when it says the 2 points, I'm going to explain what that means in a second. What I do want to do, as much as it might seem like a bit of a waste of my time, I'm just going to redraw the original graph we were given. So we were originally given F. This had a y-intercept at 1, and we know there was a coordinate at A of 4, 16. Okay, that is the original F. We are now drawing the inverse. And so what that means is that I would need to reflect this graph, obviously over a straight line, over the line y equals x. Now, this is just helpful for me to visualize what happens. However, this statement here, indicate on your graph the coordinates of 2 points, should give us a little hint. Because of this whole swapping x and y, what that means is that our y-intercept of F becomes my x-intercept of G. So this point at 0, 1 now becomes the x-intercept 1, 0, as well as the fact that the coordinate of A, which was at 4, 16 on F, now becomes the coordinate A prime, because remember it's a transformation, of 16, 4 on G. And so those are 2 coordinates I can now plot for my inverse function. Okay, so my inverse function is not going to be the most beautiful thing in the world again. I can't even draw a straight line tonight, but we'll do our best. We know where our x-intercept is, 1, 0. We know we have another coordinate here at 4, 16. No, 16, 4. Just wrote it down. You would think I would remember. And because we understand that it is a reflection of my original function, I do know the general shape. Okay, again, it's not going to be the greatest thing I've ever drawn, but there we go. There is our graph of G. You can see if we now compare the original and the graph I've just drawn, you can see that mirror image over the line. But it's just so important to remember this idea of swapping those coordinates, swapping x and y, swapping your x-intercepts, etc. Guys, this means everything swaps. So your range, for example, of F would become your domain of G and vice versa. So here, if I asked you for the range of F, this range would be y greater than 0, because remember we said our asymptote is at y equals 0 and it's everywhere above. If you now go to this inverse function, that y-axis is now my asymptote at x equals 0. And so the domain has swapped, or the range has swapped, however you want to look at it, x greater than 0. There is a swapping of characteristics in your graphs. And so honestly, if I was sitting in this exam, I probably would have asked you a question like this. What is the domain of G, or what is the range of? Okay, so when you are looking at inverses, this idea of swapping is always important. Right, there's a question of, won't the signs of point A change from a positive to a negative? No. Things only change from a positive to a negative if I am reflecting over the line y equals negative x, because that is where a sign change happens. Here, they're both positive, so there's no sign change. It's just a swap. of position, x to y, y to x. It would also only change sign if you reflected over the x-axis, so it now went below. But because it's just an inverse function, there's no sign change. Yeah, good, cool. Right, guys, I'm just going to let you take a screenshot of these three so long, and then we'll have a look at the next few. Especially because I want to draw our graph again for us so that we can see what's happening. Alrighty, Roo. So question D says use your graph to determine the values of. Now, the likelihood is that if you got a answer book, you would have sketched the inverse function on the same set of axes as your original graph. However, because obviously I've not drawn it like that because it's who I am as a person, we don't have that luxury. So I'm just going to sketch our graphs again. So this was my original graph of f. This is at 0, 1. And then obviously we have our inverse function that we've just drawn. I do see your hand. Give me 2 seconds. Okay, and there's G on 0. This would now be at 16, 4. Okay, so those are the two graphs. That inverse is absolutely shocking, but we're just going to pretend it's not that bad. Nokubonga, was your hand up? Sorry, unless I just missed that.
It's okay, maybe it was a mistake, sorry.
Okay, cool. All right, so guys, those are the two graphs that we are looking at. And the reason I'm wanting to draw them together is because in this first inequality question, it's asking me to compare the two graphs. So this first question is asking, is saying to me, where is f of x times g of x greater than 0? So where is the product of my two y values of f and x greater than 0? So where is the product positive? Product is positive. Now, when we multiply numbers, what signs do we multiply in order to get a positive product? Nice, Kanye. Very nice. Lorato, good. So either we're going to say a positive times a positive or a negative times a negative. That is the only way for me to get a positive product. And I know it's a positive product because of the greater than 0. So now I go to my graphs. Now, clearly, for the graph of f, all of these y values are positive. It's all above my x-axis. So these are all positive. When it gets to my inverse function, we need to be a little bit more mindful. These y values are all negative, but these y values are positive. Now, I think I said this on Monday, but 9 times out of 10, points of intersection, x-intercepts, those are going to be very important in defining your intervals for these inequalities. So this x-intercept is the point at which my graph changes from positive to negative. So would you agree with me that on the left-hand side here, I have got a positive times a negative? These are all positive values. These are all negative values. That doesn't work for me. That's a no-go because that gives me a negative product. However, to the right of my x-intercept, let's grab a color here, all of my y values for both graphs are positive. So I've got a positive times a positive. That's exactly what I want. And so for all of the x values greater than 1, I will get a positive product. Now, we know not to include 1 because it did not say where's the product greater than or equal to 0. At 1, it is equal to 0. And because we don't want it equal to 0, we don't include the 1. If you're going to write this as interval notation, x element of, you start with the smallest number, which would be 1 because this goes up to positive infinity. It's a round bracket because it's not included, all the way up to positive infinity. And so when you get questions like this with the product, don't panic. Do exactly what I've done. Put a little plus and minus signs on your graphs so that you can see where it's positive and negative. And then remember that often the x-intercepts or your points of intersection between the graphs, those are going to be the x values that define your intervals for you. All right, any questions about this one? Because I know that inequalities aren't necessarily our favorites, but they are doable if we find the right tools.
Ma'am, can you please repeat again?
All right, so the product must be positive. So both y values of my graphs must be positive. And if we just go to our graph, our Cartesian plane, we know that everywhere above my x-axis, y is positive. Everywhere below my x-axis, y is negative. So I want to look for a place where either both graphs are sitting in the negative region or both graphs are sitting in the positive region. For this first bit of my graph, if we read left to right, this is all positive. This is all negative on the orange graph, on my graph of G, which means I'm saying positive times negative, which gives me a negative product. I need a positive product. So that's not what I want. If I now continue on, if I now continue along my graph, I can see that the next section, F is positive and G is positive. And so what I now have is a situation where I've got a positive times a positive, which is exactly what I want because that does give me a positive product. At the point where both graphs are now positive, we can see it's at this sort of line over here where we had our x-intercept. So at that point, x was equal to 1 because that's where my x-intercept was. And so it's all values greater than 1 where I will find this positive product. So you identify in your graph which section or which region gives you the positive product or satisfies the inequality you've been given. And then at that point, you read off the x value and you essentially use that x value in your answer. Does that make a bit more sense?
Yes, ma'am.
Cool.
So, ma'am, the greater sign. Ma'am.
Say again. Yeah.
The greater sign goes along with the positive sign.
Exactly. If it had been less than 0, it would have been a negative product.
Okay, ma'am.
Good. Well done. All right, guys. The next one says where g of x is less than or equal to -1. Now, this is a bit random. It's now asking me where my inverse has a y value, less than or equal to 1, -1. Now that's, I mean, like, what on earth am I supposed to do with that? Well, I don't even know where -1 is on my y-axis because this diagram is not to scale. Aha, we do not panic. We know what g of x is. That was a little bit weird. I do apologize. Clearly, I'm getting too excited about inverse functions. We know what g of x is. We worked it out earlier. It's log base 2x. And, oh gosh. And we know that horrible x. We know that we are trying to figure out where this graph exists in relation to a y value. Because remember, g of x is another way of saying y. So I'm giving you a y value here that we need to relate back to. So why don't we just substitute that in? -1 equals log base 2x. We're trying to solve for that x, so let's just convert it back to exponential form. Remember, this is your base, so 2 to the -1 equals x. So x is equal to 1/2. The question said determine the values of x. I've got a value of x here. Now I just need to figure out which way my inequality should be for g of x to be less than or equal to -1. Now I'm going to make some assumptions here, so just bear with me. When I say some assumptions, because my graph is not drawn to scale, obviously I can't get it perfectly accurate, but we're going to be fine. So here's my inverse function. Why the inverse function? Because it was talking about g, so that's what I care about. There is the 0. No, let's just write 1. There's my x coordinate at 1. Cool. What I have just determined is that x is at 1/2. That's what I've determined. And so basically what I've established here is that the corresponding y value would be -1. By substituting in y equals -1, I found the corresponding x value. So I actually know this coordinate here is at 1/2 -1. The question asked me, where is the graph less than -1? Now, less than -1 would be everything below that coordinate. Now, remember, this y-axis is an asymptote, so I can't go past that asymptote. And so what that means is that this little portion of my graph that I now need to work with, just scroll down a smidgen, is between the asymptote and that x value of 1/2. So this is at 1/2. This is at my asymptote of 0. It's just that tiny little section in the middle there where g of x would be less than or equal to -1. Just this tiny little bit here. Now, when it is a continuous section like this, you start with the smallest value, you end with the biggest value, put x in the middle, and I don't know why I'm writing that there because that's not where the question is. Let's try that again. Start with the smallest, end with the biggest, put x in the middle, and then put in your inequality signs. In this case, it was where it was equal to -1. So we already know it's equal to -1 at 1/2. So we can put equals under the inequality. We cannot do that with 0 because remember, this is an asymptote. My graph doesn't exist at x equals 0. So it can't have an less than, greater than, equal to. And so we have established where my graph for the inverse would be less than or equal to -1. So when you get a question like this where you're given a y value that you can't read off your graph, obviously if you plotted a point and you knew where it was, great, you just read it off. Don't panic. Substitute, solve for x, and then go back to what your graph is telling you in order to figure out what the rest of your inequality should be. Right, again, any questions on this one? Again, I know these aren't super simple, so let's rather deal with any confusion we have. Right. I can't actually remember where I said take screenshots from grade 11s, grade 12s. Have you screenshotted A, B, and C? Am I right? Just give me a thumbs up if I remember that correctly. I think so. Yes, okay, thought so. Cool. Right, so we'll screenshot the rest now in a second. Let's just finish off E, but I saw there was a hand level. Level, you there? There we go.
Yes, ma'am. Ma'am, I wanted to ask for the last question. Is that the only acceptable notation, or can you also say x is less than or equal to 1/2, and then comma x cannot equal to 0?
No, because what you are implying there is that there is graph on this side. So you're implying that there's an asymptote here where my graph doesn't exist, but then it carries on the other side. We do need to limit that it can't actually go any further than 0.
Oh, okay. Thank you, ma'am.
Does that make sense?
Yes, that makes sense. Thank you.
Okay, cool. Sorry, guys, I didn't write the interval notation here. So this would be x element of open bracket for the 0, semicolon 1/2, and that would now be a square bracket because we can include 1/2 if you wanted to use the interval notation. Right, this last question, E, says, if h of x is equal to f of negative x, calculate the value of x for which f of x minus h of x equals 15/4. Lots of things, we're going to break it down. Firstly, we want to understand what this transformation is over here. Okay, so f, so many things, f of x, we worked out right at the start to be 2 to the power x. What transformation occurs when we make just the x negative? What is that transformation doing? Nice, Kani. Right, so if just x changes sign, this is a reflection about your y-axis. Right, now that's not super important because we can just substitute in a negative x, but I just want you to understand what that actually does. Now, according to my rule, what it wants me to do to get h of x is make the x in my original expression negative. So now I've got 2 to the power negative x. Now I can go to the next bit of the situation that actually tells me to subtract the 2, and I want to know where the distance between those two is 15 over 4. So f of x was 2 to the power x minus h of x, 2 to the negative x, equals 15 over 4. And now you've got an equation that you need to solve. Now, guys, there are a few different ways that you can do this. And again, you need to decide what you're more comfortable with. I would probably go K method in this instance. Reason being is because this 2 to the negative x represents don't know why I'm panicking at this. Represents, and I pushed an equals. Represents 1 over 2 to the x. Remember that negative exponent actually means a fraction. And so because of that, personally, I probably go K method. It's not the only way you can do this, but I think K method is easier. However, I'm going to give you 3 minutes. 2 minutes maybe is a bit harsh. 3 minutes to go and solve for x for me. Right, so this is practicing a little bit of the algebra that we're going to start talking about on Monday again. So let's get some practice in now. I want you to solve for x for me. And like I say, if you would like to, if you're feeling stuck, use the K method. That will be my hint for you. Alrighty, guys, let's see what we have going on here. So like I said, I would use K method. So always just say what you're going to let K equal. So let K equal 2 to the power x, which means we've got K minus 1 over K equals 15 over 4. Obviously, if you're comfortable without K method, don't use it. It's absolutely fine. I just know for me personally, I would struggle without. We obviously don't want that k in the denominator, so I'm going to times everything by k, giving me k squared minus 1 equals 15 over 4k. And then I don't particularly want that 4 either, so I'm going to times everything by 4. 4k squared minus 4 is equal to 15k. Get it into standard form, so 4k squared minus 15k minus 4 is equal to 0, and then you factorize your trinomial. Now, I was going to say some words and they've gone out of my head. If you are not super comfortable factorizing your trinomial, remember you have the quadratic formula, and it is obviously perfectly okay for you to use that. This can be factorized without the formula though. This would be 4k plus 1 plus 1, k minus 4 is equal to 0. And so k is equal to negative a quarter, or k is equal to 4. Now remember, once you've got these solutions for k, what you want to do is you want to substitute what you said k represented back into those solutions. So now we actually need to go back and put the 2 to the power x back into there. So we're going to have then 2 to the power x equals negative a quarter, or 2 to the power x equals 4. Now this first equation that we have here equals negative a quarter. That's not possible. I can't raise 2 to the power anything and get a negative. 2 to the power negative 2 is positive a quarter, not negative a quarter. It's not possible for me to get a negative. So there's no solution there. Layla, I do see your question. I'll go back in a second. Let me just finish this and then I'll go back. All right, so this first one, there's no solution happening there. But the second one, I can find a solution because we know that 4 we can write as 2 squared. And so that means x is equal to 2. And that's all the question asked me to do. Calculate the value of x. So now I know where x is equal to 2, the distance between my graphs will be equal to 15 over 4. Right, if we just quickly go back to the K method. So K method, guys, is when you have a slightly more complex expression. And when there's something common amongst terms, we can change that or we can make it represent K. So because in both of these terms I had a 2 to the power x, I decided that was what K was going to represent. Okay. Problem children. That was what K was going to represent. So in place of all my 2x's in this expression, I'm going to replace it with K. And the reason we use the K method is it just makes our lives a little easier. Rather than working with this horrible like fraction 2 to the power x in the denominator, I now just have a K. So every time I see 2 to the power x, I replaced it with a K. And then I start to solve for K. So the first thing that I saw was that I did not want K in the denominator because I don't really want a variable in the denominator. And so I started off by timesing everything by K, every single term. That gets rid of the K in the denominator. That's why I was left with 1. But K times K is K squared. 15 over 4 times K, 15 over 4K. The next thing that I didn't really want to have to deal with is a fraction. And so I times everything by 4 in order to get rid of this fraction. So that's now gone. That leaves me with 4k squared minus 4 equals 15k. And then this is a quadratic. So now I want it in standard form, ax squared plus bx plus c equals 0. That's what I did over here. And then I went and factorized. Once you've solved for k, you need to go back to what you said k represents, and you need to substitute that back in so that you're actually solving for what you wanted to solve for rather than just stopping at k. And I think that's also a little mix-up we sometimes make. We forget to go back and actually solve for x. All right, Leila, does that make a bit more sense? Perfect, cool. I know it's not the easiest thing, and like we don't actually use K method a whole lot. Some teachers don't even teach K method, but it is quite useful. You don't have to do this with K method. I'll show you what it would look like without K method. For me personally, I would find it very difficult to do it without K method. My brain just doesn't work like that. But I'll show you in a second what it would look like without. Lorato?
Ma'am, so since we said we let k equals to 2 to the power of x, when we find out the k values and find x, we don't have to now say 2, find like maybe the x value for 2 to the power of negative x. Both of the k's have to equal to 2 to the power of x.
Yes, exactly. So once you found one solution, you found the solution. Obviously, if the second solution was k equals a quarter, then you would have two different solutions for x. But the 2 to the power x is the same thing. Just because one was negative, they represent the same value. Okay, cool. So guys, just out of interest, if you didn't want to use the K method, again, like my brain just doesn't work like that, and that's okay. You don't have to use the K method, but I would struggle to do it like this. So you would have your 2 to the power x minus 1 over 2 to the power x equals 15 over 4. You would use the same logic. You don't want that 2 to the power x in your denominator, so you would times everything by 2 to the power x. Now, this first term, if you've got 2 to the power x times 2 to the power x, according to your exponent laws, you would add your exponents together and you would end up with 2 to the power 2x. So this would be 2 to the power 2x minus 1 is equal to 15 over 4 times 2 to the power x, because you've times everything by 2 to the power x. Now, this is actually a trinomial. This 2 to the power 2x is a squared term. There's your x term and there's your constant. So you do once again have a trinomial that you can go and work with. So we would have 2 to the power 2x minus 15 over 4 times 2 to the power x minus 1 equals 0. And then again, you can go and factorize the trinomial. To me, my brain can't comprehend this. My brain can't comprehend what on earth I'm supposed to factorize here, which is why for me, K method is a lot easier. But if this makes sense to you and you understand that this is technically 2 to the power x squared, this is then your x term, and then you've got your constant term, that's fine. Work with it like that. You don't have to work with the K method. Just like I said, my brain doesn't do that. So I wouldn't choose that. I do think K method makes it easier, particularly in situations like this. But there are other ways to do the same thing, and you need to do what you're comfortable with. All right, so there's that last question for you to screenshot. Anything to do with functions. Doesn't have to be something we've spoken about today. Anything. You can ask away. I know, Lebo. I've had to put them on a diet because they are a bit chonky. I know. The little orange one is still a baby, but she's growing so much. But yeah, my black kitty catty is, the vet told her she's a little bit chonky and she needs to eat a little less, which she's not happy about. She makes it very known to everyone in the household that she's not happy about having to eat less. But they're darlings. They're my children. Lorato?
Ma'am, do you mind explaining how you factorized the trinomial in the 4k plus 1 bracket being the first bracket and the k minus 4? Because for me, when I get a trinomial like that, I immediately go for the quadratic formula.
Okay, cool. So do you want me to show you the quadratic formula substitution, or do you want me to show you how I've done it?
How you've done it, ma'am.
Okay, cool. So I, for whatever reason, in my beautiful, weird brain, never go to the quadratic formula, despite the fact that I know full well that it will give me the correct answers every single time. So I make really bad choices when it comes to factorization. I always like to try factorize first. So the way I factorize is I look at the factors of my first term and the factors of my last term. Now, the more you practice this, the more you're going to start to be able to see what those factors should be. Because right now you've got factors of 4k times k for your first term, as well as 2k times 2k. Those are both factor pairs for your first term. And it would be the same for the 4. It would be 4 times 1 as a pair and 2 times 2 for a pair. So there's some options here. And like I said, the more you practice this method, the easier it becomes. Now, I know that whatever happens, when I've got my 2 brackets, when I go and distribute things out, the multiplication of the middle 2 terms will give me a k term, and the multiplication of the last 2 terms will give me a k term. And whatever those are, I have to end up with a negative 15k. And so that's going to help me decide what or how I should pair my factors. So I'm going to go with 4k and k, and then 4 and 1. And you'll see why I've put it in this exact order now. What we do is we cross multiply. The cross multiplication is the distribution step that gets you your k terms. So 4k times 4 is 16k, and k times 1 is just k. And then what I do is I'll ask myself, okay, I've got k and I've got 16k. How would I need to add or subtract those 2 k terms so that I end up with a negative 15k? Well, it would have to be a negative 16 plus k. And those then dictate my sign. So this must be a plus and this must be a minus. And those are then the 2 brackets that I have for my factorized product. So that's how I factorize. There's also different ways to factorize, and like do what's comfortable with you. And honestly, like it's smarter to do the formula than my nonsense, because sometimes you sit and you think, why am I not being able to factorize it? And because sometimes it's just not able to do so. But yeah, that's how I factorize, and it does become easier with practice. But quite frankly, you are making the smarter choice. I'm not making smart choices. And if you want to know about my absolute problem child cats, no, you can't see her right now. She's chaos. Anyways, any other functions or questions? Yeah, no, she just like crawled up under the blanket like a little, I don't know, mole child. I don't know what she is, but anywho. And now she's off. I don't know. I just live my life. Okay, guys, if you don't have any other questions, you are more than welcome to leave. I will see you on Monday where we are going to do some algebra. Really recommend you are there because it's grade 11 stuff. We probably haven't touched it since June, so we need to revise it. But I hope you all have a lovely rest of the week. Good luck to those of you who are starting with mocks tomorrow. I hope the first one goes well. And then, yeah, we will see you on Monday. Sorry, Lorato.
Ma'am, do you mind re-explaining the first question that we were marking, the G, question G?
First question that we were marking. Like the
Monday.
very first one from Monday.
Yes.
Okay. There we go. All right. I'm going to be honest. This also took me a second to understand. So what I'm actually going to do is I'm going to take off the answer and we'll go through it together. Again, guys, if you would like to go, no hard feelings. You're welcome to leave. But I'm just going to explain this one. All right. So the function h of x is equal to f of m minus x plus q has only one x-intercept at 0. Determine the values of m and q. So firstly, what did we have? We know that f of x is equal to x squared plus 2x minus 3. 2x minus 3. All right, so that is the equation that I have, but I now want to understand this whole transformation going on here. So if we take this situation in the bracket is not what I like to see. I want to have x and then plus or minus something. I don't want the x term to be second. So I can manipulate that to get the x term first by taking out a common factor of a -1. That then gives me x minus m. And that is then more in line with my x plus or minus p value. And you can manipulate whatever you want. This still means the same thing. There's nothing wrong with that. All right. We then need to understand the rest of the transformation. So what I'm going to do is I'm just going to bring this. Please don't fight with me. Okay, it's going to fight with me. So, you know, I'm just going to put the graph here. But let me just grab the graph. So, like I said, I want to understand the transformations that are occurring here. You would think this would be an easy thing to do, but apparently not. Yes, my darling. Okay, there's our graph. Sorry. Right. There it is. Stupid amount of time spent on that, but there we go. It's very helpful to have the graph. So there's my function, cool, whatever. I then go on to read the next bit of information that says it has only one x-intercept at x equals 0. So what that means is that this entire parabola over here needs to move so that its turning point is at the origin. That is what those two statements mean. I need the x-intercept at the origin. Now, in order for that to happen, this graph would need to move 4 units up, because remember, c was at -1, -4. So this would need to go 4 units up. And because this x coordinate is -1, it would have to move 1 unit to the right. All right. And so, excuse me, that means that I need to account for this in the q value and the m value over here. So a shift to the right would be x minus 1. And obviously a shift up 4 units would be plus 4. So the value of m, because m is negative in the bracket, would be positive 1, because when you substitute in that value, you would have x minus 1, which gives you the expression that you want. And q, the shift up or down, would then be equal to 4 in order to get us to where we need to be. So like I said, I struggled with this question initially as well. I had to read it a few times before I understood what was going on. But the trick here was understanding that you are welcome to manipulate this bracket. Just because it's given to you like that doesn't mean you have to leave it like that. So manipulate it to make it look like what you want, x plus or minus p, and then you can go from there in terms of what transformations need to happen in order for this scenario to now be true. Does that help? I know it is a complicated question, I know.
Yes, it does, ma'am. It helps a lot. Then, ma'am, I also wanted to ask if you can just scroll up to, I think it's E, question E. Yes, ma'am. So, ma'am, with this graph, this question, because I got confused by when they included the angle, then you explained how this is where they said makes an angle of 45 degrees. So I got confused, and then you mentioned how this is where analytical geometry comes into play. So should we get a question like this, do we just need to keep in mind that we could use the tan formula to find the gradient in order to give the equation of the graph?
Yeah, exactly. So remember on Monday I said that in your functions, sometimes we pull through analytical and sometimes we pull through